Okay, hello everybody. Am I coming in loud and clear? Let me know, ladies and gentlemen. Can you hear me? Hello, Aziz, Sarina, and Jong Ahua. Hello, how are you, Abdulaziz and Joseph? Well, there's only a few people here, so we have quality, not quantity today. Um, so a couple of things before I start. Um, Everybody should have submitted the writing assignment. How was the writing assignment for you? Was it good? Was it bad? Let me know in the chat. Um, Also, lab test 2 is next week. It's like they finish one assessment and then they immediately start another assessment. What what is going on? Um, so let me just do a poll first. I want to get your opinion on something. Um, a revision tutorials for lab test 2. Let me know if you think this is a good idea because I have 2 tutorials later today and I can make them about Maple. The difference between lab test 1 and lab test 2 is that Maple is, you need Maple for lab test 2. Okay. All right. So if people want that, then I'm happy to provide that. All right, I will keep the poll open for a little while, but let's have a look at the next section. So integration by parts, or IBP. Now, integration by parts is used to integrate products of functions. Okay, and yeah, Nicholas, you're right. It is very similar format for lab test 2, except you need Maple. You won't be able to do it without Maple. Okay, so I can see that's all right. I can see that lots of people are interested. So I'll do some later today. All right. So let me give you some of the motivation for lab test 2. So let's say I want to integrate this product, right? It's a product of x with e to the x. Now, the tempting thing here is go, oh, it's just that, plus a constant. But that's not true, right? Because if you differentiate this, if you differentiate this product, you don't get that. So the question is how to integrate products. That's basically the question we're going to look at today in this tutorial. Okay, so a few people wanted to talk about, well, what sort of stuff do you use? Well, here's a microphone and I've just moved the cameras around today. Um, so where are we going? The most important thing about today's tutorial or today's lecture is you want to simplify integrals involving products. And there is a strategy, right? So we'll basically use some examples to talk about strategy and choice. All right. Okay. So the most important, well, one of the most important things here is that the integration by parts is the product rule, but for integrals. Okay, so we know how to differentiate products but what, like how do we integrate them? And if you don't know the integration by parts formula, it's very easy to derive. Okay, so let me show you the formula, and then I'll show you how to derive it. Okay, so this is the formula here. It's quite long, but you can think of this left-hand side being a difficult integral, and this integral on the right-hand side being a simpler integral that you can usually evaluate. Okay, so this is super important, and you can see here you're integrating a product involving a function and a derivative. All right, so two functions, one's just a function, the other one's a derivative of something. Okay, it's this product minus the integral of the bits that don't appear here. So v dash is here, but v is here. U is here, u dash is here. Okay, so where does this crazy formula come from? Well, it comes from the chain rule. Okay, so let's consider we differentiate two functions, all right, where u and v are functions of x, right? We know that that is just u times v dash plus u dash times v. Okay, so that's by the chain rule. Now, all we do now is integrate both sides and rearrange. So if we integrate the left-hand side, and integrate the right-hand side, I get this. And now let's keep that there and move this to the other side. Oh, I guess I can write that as v times u dash. Okay, so if you're ever not sure about the integration by parts formula, you can always start with the product rule for differentiation and integrate both sides. That's how you can come up with it. Okay, now when you're actually solving problems, you need to make a choice. Okay, what's u going to be, what's v dash going to be, and then you calculate the other things and apply the formula. All right, so the integration by parts formula is used to integrate products. You can derive it using the chain rule, sorry, not the chain rule, the product rule. Product rule. Sorry, by the product rule. Okay, the product rule for products. You can derive it using the product rule. Okay, and all you do is rearrange. And what you hope is that this integral is simpler than this integral. Okay, that's a difficult integral. You want to transfer it to a simple integral. Okay. Yay, so that's basically it. Now, some of you will have seen integration by parts before. So if you've seen it before, let me know in the chat. Okay, let me know in the chat. All right. So, yes, that's great. Abdul Rahman, Zhonghua, Annalise, great. Steve, yes. But it's okay. If you haven't seen it before, don't worry. Okay? It's a relatively straightforward thing. Okay? So just to kick it off with steps, if you're going to integrate something like this, you need to work out what is my u going to be and what is my v dash going to be. So that's what I mean for that. Once you have that and that, you either differentiate or you integrate to get u dash and v. Then you apply the formula, and sometimes you have to apply the integration by parts formula a few times. Okay, so like I said over here, you want this and this to be compared, and this, you want that to be simpler than that. If you make it more difficult, then it's a problem. Okay, so the best way to learn these kinds of ideas is through examples. Okay, so we've got a product of a function here, two functions. And if I look up here, I need to make a choice for u and v dash, okay? So who can tell me on the chat, maybe you've seen this before, what might be a good choice for u from this integral? What might be a good choice? Okay, people are piping up and saying 6x. Okay, so why, the question now is, why did you choose 6x? Why is that an appropriate choice? It's easy to differentiate, yes. So if u is 6x, then it's easy to compute the derivative, which is 6. Yeah, it's a function, Russell, that's right. I guess if you differentiate 6x, you'll just get a 6 over here, won't you? So that's probably going to be simpler than this. So let's try it. Let's try it. So I'm going to let u equals 6x. So if u is that, the other part of the product has to be your v dash. Okay. So we've got u and v dash. We need two more things. We need u dash and v. So u dash is going to be 6. And if I integrate e to the 5x, I'm going to get 1 on 5 e to the 5x. Okay, so those four functions are all I need to apply my formula. Okay. So this is going to be our integral. So by integration by parts. Okay, let's work it out. So this is going to be your u, and this is going to be your v dash. All right, so this now is going to be u times v, so that times that, minus the integral of the product of the two things that we just thought of. So 6 times 1 on 5 e to the 5x dx. So now the question is this a simpler function than our original function? Who can tell me? Is this easier to integrate than that? Who can tell me on the chat? Is this easy to integrate or not? Yeah, I mean, this is no harder to integrate than this thing, right? So, who's that? Abdul Rahman. Cool. All right, so let's do it. Okay, so what is the integral of this? You'll divide by this exponent of 5. That's it. So Steve, I'm not sure what your question is. So u is 6x, so the derivative of 6x is is 6, right? So this is u times v, and this is the integral of u dash times v. Can you see it, Steve? So there, yeah. Okay, so let's test it. Let's check our answer by differentiation, right? So consider, please. So let's differentiate our answer and see if we get the integrand up here. Okay, so for this one, I'm going to use the product rule. For this one, I can just differentiate it normally, and this will just go to 0 when I differentiate it. Okay, so let's use the product rule on the first term. Okay, so that gets rid of the x. And for the other one, the 5 is going to come down. Okay, and then over here, the 5 is going to come down. And you can see, cancel, cancel, and that is the same thing that we started with. Okay, you can see it's here. Okay, so if we're not sure, we can always check. So let's go through that again. We were integrating a product. And one way to do that is to use integration by parts. Okay. Now, for integration by parts, it involves two choices, one for u and one for the derivative v. I chose u, one reason is because the derivative is simpler, and therefore, when you consider this, it's probably going to be simpler than that. Okay, we computed the other 2 bits, we applied the integration by parts formula, and then we checked. Okay, so not bad, not bad. So what do you think, people? If you haven't seen it before, what do you think about integration by parts? Now is the time to sort of get going with the questions. If something's not clear, or I haven't really explained anything too well, what do you think? Okay. So just to recap, you need to make a choice. What's u going to be? What's v dash going to be? And then compute the other 2 things, and then apply the integration by parts formula. Now, you also need to be careful, because sometimes if you make the wrong choice, you can actually make the problem much harder than the original problem. So that's a top tip. Okay. Yep. Carl, what's up? What do you want to see, buddy? Can you see it? Yeah, Bailey, that's an excellent question. What happens if you switched u and v dash? Okay, so if you do that, you actually get a more complicated problem. This integral is more complicated than the original integral. Okay, so one's basic strategy is to choose u where the derivative is much simpler than u. Okay. So I think, Bailey, if you switch these choices around, you'd get something like 3x squared times e to the 5x here, which is more complicated than the original expression. So it's a really good question, Bailey. Sometimes you can switch them. It doesn't matter. But in many cases, if you make the wrong choice, then this thing gets really complicated, and you don't want that. All right, Carl, can I proceed? All right. Oh, yeah. Sorry. That's right. So hang on. So all the dx's up here. You're right. So that should be a dx. I think that's what you were getting at before, Steve. That's just a little typo there. So dx and dx, and you can see there's all dx's up there. Yeah. Gosh, you've got a good eye there, Steve. Yeah. I didn't notice that. So that should be a dx, and that should be a dx. I'll fix that up when I post the notes again. So Steve. All right. So yeah. So let's do it again. Let's do this one. Okay. So for this one, this is similar to the previous one. Instead of an exponential, you've got a trig function. Okay. So for this one, we need to make a choice of u and v dash. I'm going to do the same choices as before. I'm going to let u equal 4x and v equal sine 3x. Okay. V dash. Okay. Now, of course, if you make some choices and they turn out to be wrong or not very helpful, you can just start again, right? You can just start again. So so if u is 4x, the derivative is going to be 4. And if v dash is sine 3x, the integral is going to be negative 1, 3 cos 3x. Okay? So that's really all I need, the 4 parts, to apply my integration by parts formula. Okay? So by integration by parts, right, that's going to be my u, that's going to be my v dash. We're going to get, all right, so it's going to be u times v minus the product, the integral of the product of these two things. Okay, so minus okay, so now, is this integral simpler than this integral? The answer is yes. Okay, because this has an x in it and this doesn't. It's only got, you know, cosine 3x. So that's good. Okay. So this is easy to integrate, which is nice. Okay, so I'm going to get, when I integrate cosine, I'll go to sine, and I'll divide by this 3 and the 3x. Okay. So let's check it again. See if we're actually correct. So I'm going to use the product rule. Okay, so I'll use the product rule on this, and I can just normally differentiate that. Okay, so what are we going to get? Well, for the product rule here, we're going to get something like that. Cos will go to negative sign, and the 3 will come to the front. And when I differentiate this, sine is going to cos, and the 3 comes to the front. So you can see they're going to cancel. Hooray! And we get the same thing up here. All right. So you don't obviously have to check your answer all the time, but I'm just showing you sort of that it actually works. Okay. So questions. What happens if you switch these things around? Well, instead of having 4 here, instead of having this, you'd have something like 2x squared. So it wouldn't really work, right? Like it's not actually simplifying things. Okay, so let me just make a little remark about that down the bottom. Okay. So if we let u equal sine 3x and v dash equals 4x, then sure, u dash is going to be 3 cosine 3x. That's fine. V is going to be 2x squared. So when you apply integration by parts, you need to integrate the product of this, which is a disaster because integrating 6x squared cosine 3x is much more difficult than integrating this. Disaster. Okay, so even if you're not super confident with the choices, there's only 2 options. And if you get something that's more complicated, you obviously want to change or rethink your choices sometimes. Okay, so questions, people, questions. Is anything unclear or could anything be clearer? What questions do you have for me on the chat? Silence. Okay. Well, good, Steve. Well, let's level up a bit. We can level up. Let's see how we can use integration by parts twice in the same problem. Okay. This is an annoying way to solve problems, but it's effective. Okay. So I think that's something that we should discuss. Okay. So they give you a hint in this one. They say by repeatedly, in this case, it's going to be twice. Applying integration by parts, evaluate this integral. Okay. So you'll see here, again, this is very similar to the previous example, but instead of 4x, we've got x squared times sine of something. Okay. So let's see how we might solve this problem. So who can suggest what might we make u in this? What might we let u be? X squared. Yes, it's worked so far. Why not? Let's keep going. We know that when we differentiate this, it's definitely going to be simpler. Okay. Yes. Thank you, everyone. So when we differentiate this and we integrate this, the product is going to be simpler than what's in here. So if I integrate sine x, I get negative cosine x. So they're the 4 parts that we need for our integration by parts problem. Okay. So this is going to be our u. This is going to be our v dash. Okay, so let's go and see what happens with our problem here. Okay, so let's call this I or something. Okay, so it's u times v minus the product, the integral of the product of these two things, u dash and v. All right, so it's u times v minus the integral of v times u dash dx. Okay. So u times v, that's going to be negative x squared cosine x minus the integral of the product of these two things. So that's going to be plus 2x cosine x dx. So now the question is that simpler than that? And the answer is yes. This is simpler than that. Okay, but we can't actually integrate this straight away. So, but this is also a product. So let's make another choice. Okay, let u equal 2x and v dash equal cosine x. Okay, so if u is 2x and v dash equal cosine x, then let's differentiate u to get u dash. And we'll integrate v dash. That'll be sine x. So now let's run the whole thing again on this integral. Okay? So we'll keep this. Okay, u times v, that times that. So 2x times sine x minus the integral of this product. Is this integral simpler than that? Yes, it is. So we have one integration and then we've finished the problem. Phew! Oh, so much hard work. Okay, so if we integrate sine x, we get negative cosine x, and the minus sign will cancel out. Yay! We did it! Yay! Awesome! Okay, so with that one, we did it twice. Okay, sometimes you do it more than twice, but it's a bit, it's a bit time consuming, right? It's a bit time consuming. All right, questions for that one. Let me know what is happening in the chat. Actually, I can probably just turn everyone's microphones on there. If you want to chat, you're welcome to chat with me. I've just turned everybody's microphones on. So if anything isn't clear or you want me to repeat something, just let me know. Okay? So repeated IBP. That's the most important thing for this example. Okay. All right. So a good question here is, well, what happens when these are definite integrals where there's numbers in here. Okay, so this is still very easy. You just put in the numbers at the end. Okay, so let's do a simple example here. Let's make that be u, that be v dash. Tom, let me have a look. Was that the previous example? Yeah, in the previous example, v dash on the first one was sine x. Is that what you're looking at there, Tom? Let me know, buddy. Hello, Tom. No, did I? I thought, no, v dash for the first lot, right? So from this one, v dash is sine x. When we apply it again, we make different choices. Okay, so I'm writing different things because we do it once and then we redo it with different choices. Does that make sense, Tom? So these things refer just to here. These things refer to here. Okay, so when you apply it twice, sometimes you have to change your choices. Okay. Cool. All right. So this is again a pretty easy one. The only thing that's different is the limits of integration, and they're easy to manage, right? So if u is that, u dash is going to be 3, and v is going to be the integral of that, which is this. Okay, so let's integrate by parts. Let's see what happens. Let's call this I or something. Okay, it's going to be u times v and this is because it's a definite integral. We want to use the fundamental theorem of calculus to evaluate this, minus the definite integral of this product. Okay, so the only thing there is one extra step with these numbers here. Okay, and obviously you need to do this integral as well. Okay, so if I substitute in 1, it's going to be e to the 2. If I sub in 0, I'm going to get 0. And over here, this is an easy integral to integrate. I just keep the exponential and divide by 2. And the last step is to put these numbers in. Okay, so that's going to be 3/4 e to the 2 minus e to the 0, which is 1. Something like that. Okay, so it's going to be something like that when you work out the algebra and the arithmetic. Okay, so in that particular example, because it was a definite integral, you just get a number here. You don't get like a function like we did in the previous ones, right? So I mean, here we got a function as our answer because there's no numbers in the integral sign. Okay, so again, pretty easy. Now, what about this strategy for making the choices? In a previous slide, I said, oh, let's make appropriate choices. And we wanted this integral to be simpler than the original integral, okay? So let's look at an example where it's not quite clear what choices to make. So this is a classic example, okay? And if you've seen it before, let me know how you would integrate this. This is natural logarithm of x function, right? So if you've seen this kind of idea before, let me know on the chat. Let me know, okay? Because you look at it, it doesn't look like a product for a start. And integration by parts is all about products, integrating products. So what do we do? What do we do? I don't know. I'm not sure. Okay. So let me know on the chat. How would you do this one if you want to do integration by parts? Ooh. Ooh, Rami is sort of turning it into a product. So that's kind of what I'm getting at when I say factors of one. Okay. So Farhan, that's interesting. I like your choice as well. Farhan, what would you choose for V dash? If U is log X, what? Yeah, see, I think some of you are very comfortable with this, right? Which is good. So this isn't a product, but I can make it a product by inserting a factor of one. Okay, so insert a factor of one. Now, for this one, we don't want to let that be U because if I differentiate one, I get 0. So it doesn't make sense to let that be U. I'll let the other part be U and let this be V dash. Okay, because when I integrate it, yes, I get something that's more complicated, but actually in this situation, it's going to help us a bit. Okay, so what are we going to get? Well, the derivative of log x, who can tell me what's the derivative of log x? Natural log of x, who can tell me? Good, Joseph, thank you. And the integral of 1 is just x. Okay, so we've got our 4 parts. Let's put them together and we can see what happens. So this integral it is the product of u with v minus the integral of the product x times 1 on x, right? So x times log x minus the integral of this product. Oh my goodness, they cancel out. So the integral of 1 is just x. So is this integral simpler than this one? You bet. So we are very happy. Okay. And so let's check it. If we differentiate our answer, do we actually get log x? Let's see. Okay, we apply the product rule to the first one. That becomes -1, that becomes 0. So log x plus 1 minus 1. So we are absolutely delighted. We couldn't be happier. So happy. Okay, so happy. All right, here's one for you to think about. Let's use green. The integral of x times log x. the integral of x times log x. It's a product. What do you think your choices could be for this? What would you choose u and v dash to be? Abdul Rahman, what do you think? Have you got your hand up?
I'm gonna try to speak, sir. Can you hear me?
Yeah. You're coming in loud and clear.
Sir, we could just make u x and v dash natural log of x because now we know what the integral of the natural log of x is.
I got myself on mute. Lol. So let me get that right, Abdul Rahman. You're saying v dash is log x and u is x. Is that correct? Okay, I think that's a good start. I think that's a really good start. So maybe you could let u x be u and the other part be v dash. But that's something for you to work on. Okay, so I'll leave that with you. Integration by parts is amazing. It's amazing. And it's a very powerful technique. And it's the opposite. It's the opposite of the product rule for differentiation. You can use it for integrating products of integrals. Now, it doesn't work for everything, but it's a pretty good strategy when you want to attack integration problems. Okay. All right, everyone. We have got 4 minutes. What do you want to talk about? What would you like to talk about? We have lab test 2 next week. I'm going to do some revision on today. I'll do some revision. What do you want to talk about? We've got 4 minutes, 3 minutes. Let me know. Serena, I'll do one at noon Sydney time, and also let me check my calendar. Yeah, no, sorry, 2 p.m. and 4 p.m. Sydney time. Let me put that in the chat. Yeah. So what I intend to do is just work through the practice problems and show you how to, use the Maple or because Maple will be, I think, at least more than half of the total test. Yeah, Steve, today I'm going to do it today, buddy. I might do one on Monday as well, but that's like that's a bit close to the test. Let me just have a look. What's happening on Monday? Yeah, that's a noon tutorial on Monday. It depends. Yeah, John Hua, I'm going to record it. Absolutely. I'm going to record it, so don't worry. Yeah, understandable, Hawk. Understandable. We don't want it to be awkward for you, right? So, yeah. So and it just depends if people see value in it, right? Hopefully it's valuable for you, whether you're there. Oh, Bailey. So, yeah, good question, because there's lots of tutorials. So it's yeah. So 2 p.m. is the deeper understanding, not deeper. And 4 p.m. is balanced. Okay. Oh, the captain has arrived. Yeah. How you doing, Bill? We just finished a little early. We're talking about lab test 2. If only, Bill. If only. Right. In today's lesson, Hawk, nothing. For my group, nothing. But the deeper understanding is where you do the H questions and maybe some of the more difficult problems. And the balanced is you just, it's sort of in the middle. Does that make sense, Hawk? So if you want to do the really hard problems, you go to the deeper understanding. If you want somewhere in the middle, you just do balanced. If you want the easy basic stuff, you go to foundational. Yeah. All right, folks. I will say goodbye. Nobody's commented on Iron Man yet. I put Iron Man in, and no one's commented. I'm crushed. I'm crushed. Anyway, I will say goodbye, and I will hand you over to Bill. And see you later. Maybe see you later today for some of the tutorials. So Bill, I'm just saying, Bill, that I'm going to do some lab test 2 revision today in the tutorials. Okay.
Fantastic. Excellent.
So I will see you. Thank you for a great flight. Enjoy your flight with Captain Bill, and see you later, everyone. Bye.
See you, Chris.